Good morning, you guys. I'm currently working on page 3 and page 4 of the Unit 2A packet for algebra. Today I'm just going to look at some properties of equality and then we'll take a look at a few examples. So you guys feel free to follow along and, pause, rewind, fast, rewind and fast forward as necessary. So I'm just going to go ahead and get started. So the reflexive property, that's just saying that a number is equal to itself. It literally says that right there in the meaning. So 7 is equal to 7. If we're in a problem and we set x as a variable, like x as a value, then throughout that problem, x is equal to x. Um, for symmetric property of equality, that's just meaning the equality, like equal sign in the middle, holds for both sides. So if we're saying, like, yes, this is really good right here. They said it really nicely here. Though they will still be equal even if the order is changed. So 7 is equal to 7. Also, we could flip that around. And we can also say like 7 is equal to 9 minus 2. And 9 minus 2 is equal to 7. So both sides of the equal sign are equal to each other, no matter how we flip it. The addition property, the addition property of equality says that if you have two numbers that are equal to each other and you add the same number to both sides, then they're both going to be, the resulting terms are both going to be equal to each other. So for example, we know 9 is equal to 5 plus 4. And if we add 2 to both sides, we're still going to have an equivalent expression. I actually ran out of room on my box, but in your box you should see that both sides equal 11. So what this is saying again, that if you add the same value to the both sides of the equation, they're already equal to each other, then it does not change the equality of the equation. And the same thing applies for subtraction. So we said 9 equals 5 plus 4. So what if we subtracted 2 on both sides? What if I said 9 minus 2 is equal to 5 plus 4 minus 2? This is going to give me 7. 5 plus 4 minus 2 is also going to give me 7. So I see that the equality still holds. The property of equality still holds for addition and subtraction. Let's continue to explore. It holds for multiplication as well. So if two numbers are equal to each other and I multiply them by the same number, I'm still going to have that same equality. So if I have 9 on this side, I'm going to just multiply it by 2. If I don't know why I make these boxes so small, but you'll see that 18 is equal to 18. So we're able to multiply equal objects by the same number and the equality does not change. And this applies for division as well. But you guys should notice here that we do have a restriction with division. And C is not equal to 0. And why do we say that C does not equal 0? Because in that case, our answer would be undefined. Ooh. So make sure you're making that note on your paper as well. If C was equal to 0, then our answer would be undefined. But say if we divided 9 by 3, that's the same thing as dividing, because 18 over 2 is equivalent to 9. Those are equivalent expressions. We see that up here by the symmetric property. So when we divide both sides by 3, the equality doesn't change. And the substitution property of equality just says if A is equal to B, then anywhere throughout the equation you can replace A with B or you can replace B with A because they're both the same thing. those are like the definitions. I kind of went through that mighty fast. But we're going to take a look at some examples and hopefully the things start to make a little bit more sense. Okay, I'm looking. All right, I'm back. I was missing a problem on the bottom, so I had to go add that page in. Okay, so let's go ahead and take a look at number 1. It says fill in the missing reason for the argument shown below. Well, it doesn't say below, but I'm gonna use this orange dot so you guys can like follow along since I don't have like a document cameras to like point my hand. But here, this was the question I was given. Then I used a distributive property to get to this line. And they just multiplied the 5 out to everything inside that first set of parentheses. So I got the 10x plus 20. But how did they get here? And how did they know it was equal? Well, let's take a little bit closer look at what's going on here. So they said 10x plus 20 is equal to 50. And then they subtracted 20 from both sides. So that's giving me a hint right there. So I'm going to give that as a tool for you guys to use as well. I would say it would be very useful if you guys identify the operation that's going on. So I see they subtracted 20 from both sides. So that looks to me like if A is equal to B, then A minus C is equal to B minus C. And in this case, A was 10x plus 20, and B was 50, and C was 20. So I'm going to say for 1, that would be the subtraction property of equality. And to the side, I'm just going to write what the parts were if I'm using this model. So for number 2, let's see, walking through. This is what they gave us. Then we use the distributive property, multiplying the 3 out to everything inside the parentheses, no problem. Then we subtracted 12 from both sides. Then we got down to this line. And how, well, actually the answer's over there, but yes, this is the division property of equality. Because if 3x is equal to 6, then x is equal to 2. Because we could divide both sides by 3. We're dividing both sides by 3. So in this case, A is 3x, B is 6, and C is 3, not equal to 0. So it follows our rule. Because remember, we said up there that as long as C is not equal to 0, that we're allowed to do that. 3. Oh, it looks pretty similar to what we just had in number 2. So yes, if 3x is equal to 9, then x is equal to 3. We can use the division property of equality and just divide both sides by 3 because 3 is not equal to 0. Number 4, okay, so it says A is equal to B, and this is the equation they're giving us, A plus 3B equals 20. But they're saying that we could say B plus 3B equals 20. So I noticed they took the A out. So that's the first thing I peeped. So my mind, is automatically going to go to substitution because I'm thinking something has been substituted. And actually it has, because if we take a look, they said A is equal to B. So then they just replaced this A with B because they're the same thing. So that's like saying if 5, I may be doing too much for these examples, but if 5 is equal to 3 plus 2, and 5 plus 3B equals 20, so that would be 5 there. Then I can replace that with 3 plus 2 because I know they're the same value. I know these two are the same thing. Oops, I thought that was the highlighter. I know these two are the same thing, so I can interchange them as I feel free. So yes, I'm going to go with substitution for that one. Which answer choice properly reflects the multiplication property of equality? So what we really need to do, y'all, is just look for which answer choice is using multiplication. This right here looks like addition. No. That looks like subtraction. Now C is giving me the vibes. C looks like multiplication. So I'm going to keep C, but I'm going to just keep looking at my answer choices to see if there's something better. But D is actually division. So I'm going to X that one out. And I know the answer is going to be C. And I simply know that just because I looked at the operations. So they're saying if two numbers are equal to each other and I multiply them both by a third number, I'm still going to have the same equality. The same equality will hold. That's all they're saying. 6. Which property justifies the following statement? If A is equal to B and B is equal to C, then A is equal to C. We really didn't go through this in the properties above, so I do apologize for putting this on here. But I would say that this is the transitive property. But, I mean, we could also say substitution as well, because, but I really think the answer was transitive. If A is equal to B, right, but B is equal to C, I can substitute C for B. So wherever I see a B, I could put a C. So wherever I see a B, I could put a C. And that's how I could get that answer. So I'm going to put a little asterisk. And I'm going to let her clarify that one in class. So please verify with Ms. Lucas. I'm going to put it in words, and just in case y'all are just fast forwarding through the video so y'all will see it at least. 7. So for this one, they already give us the equation. We just have to see what operation they're doing. I see they have an equation, and then they divide both sides by a common term, W. They divide both sides by a common term. So what is that? The division property of equality. Self-explanatory, right? Let's see for 8. They gave us the expression, and then let's see what's the operation going on. I see this dot. I know what that dot tells me. I know what a variable outside of a parentheses means. So you guys should be saying multiplication property of equality, because that's the operation that's going on here. Let's take a look. Okay, so here, what are they doing? They started with this, and they subtracted negative 35 on both sides. They subtracted negative 35 on both sides. So they have an expression where both sides were equal to each other, and they subtracted a common term, a common number, negative 35. That's the subtraction property of equality. So there really isn't much to it. It's just looking and seeing what operation are they doing. So what operation is this? They don't have no dots, so they may be trying to like confuse you guys. But I'm pretty sure that you guys have already noticed it and may have it written on your paper. They started with this, and then they multiplied both sides by 76. So that's going to be multiplication, the property of equality. So for these, I guess I would say it's like a tool. I really would just say look and see what operation they're doing. How did they get from the first statement to the second statement? What did they do? Look and see what operation they did in between there, and more times than likely it'll be that property of equality. So yes, this is page 3 through 5 of the Unit 2A packet. And I would just say, please verify number 6 with Ms. Lucas, because I'm unsure if it's A or D. But yes. Please let me know if you guys have any questions. Feel free to come back into the call because we're going to be there for the duration of the class period. You guys enjoy the rest of your day. Bye bye.